Hey there, Great Force. Our today's math lesson is looking at another math operation. Last week and the week before last, we were doing multiplication. We're going to be doing division now. And division is, we're not going to spend quite as much time on division because it is the opposite of multiplication. And a lot of the stuff we covered in multiplication, it's the same stuff we're going to do in division. So things like multiplication families, it's still, you can still call it a division family, really, because it's the same sort of deal. So division is, simply put, it's taking a number, some sort of quantity, and dividing that quantity up into equal parts. So that means that each part that you chop it up into has got an equal number in it, an equal value. And the interesting thing about division is we use division all the time. It's one of the most used operations. The thing is, you don't realize you're using it. So I remember when I was a kid, we used to play ball hockey all the time, and what we would do to make teams fair is we would take our sticks, and we wouldn't play at school, we'd play after school, and we'd throw all the sticks into center ice. So the sticks would all be piled on top of each other in center ice, and then one person would come to the pile, and they would take two sticks and throw them in opposite directions on different sides of the ice surface, or the playing surface. And they do that with every single stick. One would go on one side, one would go on the other. And at the end, all the players would just find their sticks, and whatever side you were on, that was your team. And so that's basically what he was really doing. What we're really doing when making those teams is we're just dividing by two. We're taking how many players we have. So we have 12 players or 14 players, throwing the sticks on either side. Well, you got seven people on each side, and because it's random, hopefully the teams will be fairly even. So that's sort of one of the things we used to do as a kid. What we really were doing is dividing, and you don't realize how often you do this on a daily basis, but you do it all the time. So, for example, how many pieces of pizza can we each have? If we have a 12 slice pizza, how much does that leave for each person in a family? If there's four people in the family, how many players will be on each team? So you guys do this at recess all the time. You're playing football, you're playing soccer, you want to make the teams even, you divide everybody in half. If you play captains, one person picks, then the other person picks. You're dividing by two, right? How many candies can I buy with my money? So if you want to buy, I don't know, say you're buying popsicles or lollipops or something, and you want to see, you got $4 and you want to see how many you can buy, well, you're really doing division. Or the one that I sometimes use is how many coffees I can get with my Tim's card. So if I have a Tim's card with $10 on it, how many coffees will that buy me? Video games. There's tons of division in video games. You just don't realize it. How many coins per level? How much wood do you need to craft a plank or something like that, or a staircase or something? So these are all things that you do on an ongoing basis. You don't realize how mathematically good you are, but you actually do this stuff often. And in fact, division is the most commonly used mathematical tool in life, or one of the most commonly used mathematical tools in life that we see. So we're going to start by looking just at a very simple division problem. So let's say you and your friends, your five friends, are splitting a bag of candy. You get a package of 25 mini chocolate bars, and you're going to split them up evenly between the five of you. So what you need to do is, between the six of you, sorry, you and five friends, what you need to do is figure out how you're going to divide these up. Well, you probably will divvy them up just by passing one to each person. So we're going to divide 25 by 6. In division, we write it this way. The division symbol is this line with two dots, one on either side. Almost looks like a T or a cross, except that there's two dots instead of another line. So we're going to take a look at what this might look like on a number line. So our number line is going to end right here at the 25, because that is the number of candies we have. So the first thing we're going to do is we're going to pass out 1 through 6 candies. So from 0 to 6, those are going to be passed out. So there's from 0 to 6, I have 6 candies passed out. Now I'm going to go and pass out the next group of 6 candies, and then the next group of 6 candies. Well, I still have some left, so I'm going to pass out the next group of 6 candies. Now I realize I only have one more candy left before I get to 25. So right now we have to stop. We can't divide it up anymore. So in that case, 25 divided into 6 groups, or groups of 6, equals 4. In other words, if I divide it into 6 groups, I'm going to have 4 candies for each person. and there'll be one left over, and Mr. G gets the one left over. So 25 divided by 6 is going to give you 4. All right, so let's take a look at this problem, right? We're going to divide 38 by 8, and we're going to do this by skip counting, which is really what we did here. You'll notice we skip counted, right? We skip counted by 6, and we said, well, how many 6s do we have? And that's basically what we did. So we're going to do the same thing here. Let's divide 38 by 8. So I'm going to skip count by 8s until I get close to 38. So 8, that's 1 8. 16, that's 2 8s. 24, that's 3 8s. 32, that's 4 8s. And I can't go anymore because there's only 6 between 32 and 38. So 38 divided into 8s, I have 4 8s. So my answer then would be I have 4 38 divided by 8 is 4 with 6 left over. So if I was going to show that with manipulative, so I have my 38 here in rods, my 1s here. So I'm going to take those and I'm going to divide them up. First, I'm going to take my rods and divide them into 10. So here I actually have 38 little dots, right? So my 38 little dots, I don't know why I have that there. I'm going to get rid of that. So my 38 little dots are going to then be divided up again. So let's take a look. Here's my skip counting line. So I'm going to take my 38 little dots. There we are. And I'm going to divide them up just as if I was giving them out. So just like candies, if I'm going to give them out, I'm going to give them all out to my to 8 different people. So if I divide them into 8 different groups, right? If I go 1, 2, 3, 4, 5, 6, 7, 8, and then take the next 8 dots, 1, 2, 3, and so forth, I'm going to end up with 1, 2, 3, 4, 5, 6, 7, 8 groups of 4, and there's going to be 5 left over. So if I take the number 38 and divide it by 8 groups, I have 4 in each group. So, and then there's 6 left over. So 38 divided by 8, divided into 8 groups, gives me 4 in each group. So 38 divided by 8 is 4 with 6 left over. So let's take a look at these. If I was going to divide the following numbers by skip counting, this basically gives me an idea of how I'm going to do this. So 8, whoops, I'm just going to move this down. 8, 16, 24, 32, 40, 48, 56, and then I'm done because there'll be a remainder. So 62 divided by 8 is 1, 2, 3, 4, 5, 6, 7. So my answer then is 7, right? So that's how you do this. I'm going to give you a few questions like this to try, and we'll go from there, and we'll see how you do.